Welcome back to my session. As a part of our InfyTQ DBMS training, today we continue with Relational Algebra part 2. Okay, last session we discussed Relational Algebra, what is Relational Query Language and what are the types of Relational Queries languages. Okay, before we start the session, please subscribe Eazy Btech. It is very useful for your career. Okay, last class we discussed about what is the relational algebra and what is the relational calculus. Okay, the relational calculus is classified into two types, relational algebra and relational calculus. Again, relational algebra is again classified into two types, basic operations and derived operations. Please go through the previous session, then you know what are the basic operations and relational algebra. Today we continue with relational operations. What are the relational operations? Derived operations in relational algebra. Okay, what are the derived operation? Okay, before we discussed about the session, please remember these entities: one employee table and one branch table. 1 minute. Okay. Yes. Derived operation. The derived operation is also called as a join operation. What is the use of join operation? Join operation is a relational algebra. It is a procedural. I think already yesterday we discussed procedural language and non-procedural language. Procedural language is nothing but we have to give some set of instructions to the system to retrieve the data from the database. Based on the, we have to give some procedure. Based on the procedure, we can access the data. That is called as a procedural language. As a part of procedural language, derived operation means join operations. Basically, join operations are classified into three types. Okay, natural join, outer join, and equi-join. Yes. What is the use of join operation? Join operation is used for combining the two different queries, two different entities based on the given condition. Basically, we have two tables: student table and student course table. In a student table having total 5 attributes. In a course table having 2 attributes. First, inner join. What is inner join? The inner join keyword is a select all the rows from a both tables. All the rows from the both tables. Okay, here it is used for to select all the rows. Okay, all the rows from the both tables as long as condition satisfied. What is the condition? What is the syntax? Select table dot column 1. Here we are using table dot column 1, table dot column 2, table dot column n. We are representing with table name with attribute name, table name with attribute name from table 1. Inner join. Okay, table 2 on table 1 matching columns equal table 2 matching columns. Okay, means here inner join is nothing but just like a intersection. Okay, it print only common fields in a table 1 and table B. What are the common fields in table A and what are the common fields in table B? Okay, in this example, okay, in this example we have a student table. In the student table we have her rule number 1, rule number 2, rule number 3, rule number 1, rule number 2, rule number 3, 4, 5. We have 1 to 8 rule numbers, but here we have 1, 2, 3, 4, 5, 9. Okay, what are the common? What are the common in both tables? We can retrieve only those values. Okay, that's why here we have to write a condition: select table column name. Okay, select table 1 and table 2, inner join table 1 matching columns equal table 2 matching columns. Okay, what are the common fields? What are the common fields? Only those common fields will be, we can get the output. That's why here we can get select student course. Okay, student course ID, comma, student name and student age from student. Inner join student course on, what are the student rule number equal course rule number. Okay, student rule number equal course rule number. Student rule number. What is the student rule number? 1. Here also 1. Okay. 2, 3, 3. Okay, that's why here course ID. We can get only what are the common? 1, 2, 3, 4 and 5. Okay, only we can represent only 1 2 3 4 1 2 2 3 1. Why? Because here only these are the common 1 2 3 4 up to 1 2 3 4. Course ID and rule number. What are the rule numbers? Is a common in the both tables. We can get only those values only. That's why here Harish, okay, course IDs and age. We are what are the attributes we want to print? We print course ID, name and age. Okay, the inner join is used for to print common values in a both relations. Okay, next one is left outer join. Okay, what is left outer join? Okay, what is left outer join? 1 minute. Yes, what is left outer join? This join returns all the rows of a table on the left side of the join and matching rows for the table on the right side of the join. These rows of the rows for which there is a no matching rows on right side. Okay, commonly the left outer join is nothing but it print all the values of the left to relation. Okay, what is the syntax? Here we have a syntax. What is the syntax? Okay, select same. We are printing the table name dot attribute name. Okay, select student name. What are the fields we want to print? This is a domain. Student name, student course. Only we are selecting the only two fields. What are those? Student name and student course. Okay, course ID from the course ID. Okay, course ID. Okay, student name, select student name dot student course and course ID dot from student left to join student course on a student course rule number equal student rule number. Okay, we have a two tables, course table and student table. What are the common things? Again same. Okay, 1 2 2 3 1. Okay, please check here. We can get all the values and also common values. Okay, Harish is common, Pratik is common and Riyank is common. Okay, here what are the fields common we have? Okay, rule number 1 is common, rule number 2, rule number 3 and rule number 4, rule number 5. Rule number 6 is not available, rule number 7 is not available, rule number 8 is not available. Okay, that's why we print rule number 7. Who is rule number 7? Okay, rule number 7 is Dhanraj. Rule number 6 is not available in the course table. That's why rule number 6. Who is rule number 6? Dhanraj, Rohit and Neeraj. Okay, if Dhanraj, Rohit and Neeraj is not available in the course ID, that's why here we print the null value. But basically what is the left to join? Left to join is nothing but it print the what are the attributes we are selecting from the left to entity. Okay, left entity. What is the left entity? In the left entity we are selecting only what are the fields we are selecting. Okay, name and course ID from student. Okay, from student appear the left to join. Okay, here you are appear the left to join and student course. Okay, student course and student course rule number equal student rule number. What are the common things? Print those values as well as remaining values. What are the remaining values from the student table? Okay, this is about the left. Okay, next right join. Right join is a reciprocal of the left to join. Okay, here this is the reverse of the left to join. Left to join means it print the what are the common fields in right side. Okay, select student dot name, select student dot name, student dot course ID from student, right join. Here we have to perform the right join. Okay, student course we are perform the right join and the student course. Okay, what is the student course? Here we have a student course. This is a student course. Okay, student course having some course ID and rule number. Okay, course ID and rule number. Student course and student course and student course rule number equal student rule number. Okay, what are the attributes we retrieve? We want to retrieve some student name and student course. Okay, student name from the student and student course ID from the student course. Okay, we have only rule number 1, rule number means course ID 1, 2 and 3 is available. Yes, rule number 1, 2, 3 only available. 1, 2, 3, 4. We are not available. Rule number 5 is available. Sorry. some 9, 10, 11 is not available. Okay, that's why it print only 1, 2, 3, 1, 1, 2, 3, 1. Please check here. Course ID 1, 2, 2, 3, 1 means up to here. These values, these are the common values. What are the common values? Those values, and rest of the values. What are the rest of the values? Okay, Dhanraj, Rohit, and these values. But here this is a right join. Okay, right join. That's why here these course IDs are not available for. Sorry, course IDs are not available. These course IDs not having any names. Okay, 454. Okay, 454. 454, 454. The 454 course IDs is not selected by any student. Okay, any student. Okay, actually rule number 9, rule number 10, rule number 11, these students are selected, but these students not belongs to student table. Okay, these are other students. Rule number 9, rule number 10, rule number 11. These students are not available in the student table. That's why this is the left student table is the left and this is the right side. Okay, right outer join is nothing but common values and all the values. What are the values? What are the, here we have, these are the common. This is 1, this is exist, this is exist, this is exist, this is exist. It is not exist, it is not exist, it is not exist. That's why here we get null value. Okay, these course IDs rule number 8, 9, 10, 11. These rule numbers course IDs are not available in corresponding students. That's why here we print null, null, null. This is about the right join. Okay, this is about the right join. Next, fully join. What is a fully join? Fully join is nothing but, okay, what are the common things? It remove the common things. Okay, select table, same, select table, column 1, table 1, column 2, table 2, column 2, like that we have to write all the columns and we print. Okay, match the column, common column in the both tables. What are the common columns? It print common columns here and table A and table B. Okay, what we are selecting here? We are selecting name and course ID, same name and course ID. Okay, common values here, these are the common values. First it print the all the values, and this Dhanraj and Neeraj and Rohit not having any course ID, same values, and remaining 9, 10, 11. First it print the common values. What are the common values? These are the common values. Up to here these are the common. 1 minute. Okay, I would like to change. First remove all those things. Okay. First common values. Okay. That is available rule number course ID 1, course ID 2, course ID 2 and 3, 1. Okay, please check this table. Okay, course ID 1, course ID, rule number 1, course ID 1, rule number 2, course ID 2, rule number 3, course ID 2, rule number 4, course ID 3, rule number 5, course ID 1. Means these students, okay, 5 students is a common in student table and course table. First it print the same values. Okay, that's why first print the common values, then next values in the left table means student table. The Dhanraj, Rohit and Neeraj, those students not selected any courses, that's why it prints null values. And in the course table we have rule number 9, rule number 10 and rule number 11 means course number. These are the rule number 9, rule number 10, rule number 11. Okay, these students, okay, these rule numbers not having any name of the student table. Okay, please check here. Okay, suppose rule number 9, rule number 10, rule number 11. These rule numbers not having in the student table. Actually we have 1 to 8, 9, 10, 11, 9, 10, 11 student rule numbers not having in the student table. That's why the student name is, it print the student number is null. This is about the fully joined. What is a fully joined? Fully joined is used for to print the common values and Cartesian product of the each and every value. This is about the fully joined. Okay, that is about the relational algebra. Now we go with the relational calculus. What is the relational calculus? What is the relational calculus? Relational calculus is relational calculus. What is the relational calculus? Relational calculus is a non-procedural query language. Okay, it is a non-procedural query language. This is a non-procedural. I think already last session we discussed what is the procedural, what is non-procedural. It is a non-procedural query language. Okay, what is non-procedural query language? We are not specified any steps. Okay, just directly we have to give query. Okay, I want only some rule number 505. Okay, we are not specified 505 is a boy. 505 is a boy. He is some 5.5. His height is 5.5. Okay, he is wearing some white color shirt, and we are not specifying any steps. We are not giving any specifications. Just directly we are informing I want rule number 505. That is called as a non-procedural query language. Okay, non-procedural query language. Okay, no specifications. Here we are not giving any no specifications, whereas in the procedural language we are giving some specifications. We are not giving any specifications, no specifications. Okay, just only what to do, how to we are focusing only what to do and how to get the particular data. Basically, again, relational calculus also divided into two types: tuple relational calculus and domain relational calculus. What is the tuple relational calculus? The tuple relational calculus is proposed by EF Card. I think already you remember EF Card. Who is EF Card? EF Card. Okay, EF Card is developed a data model. What type of data model? Relational model. Right now around 60 to 80 companies are using relational model only. Okay, EF Card was developed a relational model. Okay, same EF Card introduced a TRS, tuple relational calculus. Okay, this is a tuple relational calculus, is a non-procedural. Okay, and it work only on the rows. It work on the rows. Okay, in tuple relational calculus it basically it is filtering. Okay, what is the use of this particular relational algebra? Okay, relational query language is used to filter the data and we can access the exact data. Okay, user has to give some instruction, based on that instruction only we can access. Okay, it work on the filtering of a tuple based given condition. What is the syntax? Means what is the notation? Okay, T. Okay, this is a filtering. Here we have to filtering. This is a notation. Okay, left hand side and right hand side. Okay, here we are giving the result tuple. Okay, what are the tuples you have to required? You have to write this particular tuple, and here condition you have to write the condition. Okay, I am explaining this with example. Okay, we have to table. What is the table? Student table. In the student table we have a student ID, student name and age. Okay, T dot student name. I wanted to print student name. Okay, student name. Okay, it working on the student name. From what is the relation? What is the relation here? The relation is student. The relation name is student. The entity name is student. And here we have to write the condition. This is the condition. Okay, this is the condition. This is condition. What is the condition? T dot age. Okay, T dot age is 20. Okay, how many tuple? How many rows in the particular table? 1, 2, 3, 4, 5. We have total 5 rows. But here I wanted to print student name, only student names. I wanted to print student names. Okay, what is the condition? T dot age greater than 70. T dot age greater than 70 is nothing but, okay, first of all Sai. Okay, what about the age of Sai? 20. That's why Sai is not possible. Next, Ravi. Okay, Kumar. Okay, again Ravi. Okay, please check here. We have two Ravis. Rule number 504 and rule number 567. Okay, two Ravis are different, but 504 Ravi age is 21. 567 Ravi age is 20. Okay, but here what is the condition? Okay, T dot age. T is nothing but what is the relation name? Student. T dot age means that particular relation name. Okay, student dot age greater than 20. Okay, then this is the condition. What about the output? Okay, from the above query we can see the two parts. Okay, we have two parts separated by the symbol. This symbol is called as a filter. Okay, it is used for filtering. The second part is where define the condition. Okay, it is used for define the condition. The first part is specify the field which we want to print. Okay, here we write T dot student name. Okay, that's why print that particular student name. Total values. Okay, what is the condition? T dot age greater than 0. That's why here out of 5 rows we can get only 3 students data. Why? Because only 3 students having more than age greater than 20. Remaining 2 students are less than I think 20. Okay, that's why that is less than 21. Okay, next second one. What is the second one? Okay, T. Okay, T is nothing but total. Here we are representing T is nothing but total relation. Please check here. In the previous we have to give T dot student name. Only I want only particular name only particular column. But here we are representing T. T is nothing but I wanted to print total table value. Okay, what is the T? T represent what? Student. And okay, and T dot student name equal Ravi. Okay, T dot student name equal Ravi. I wanted to know total information of a student name having Ravi. Okay, who are the student name having Ravi? I want total information. Total information is nothing but T represent total information. Okay, total query, total data, total number of tuples. How many tuples you have matching with the condition? We can get that one. Okay, here T dot student name equal Ravi. Okay, total how many rows in this particular table? We have total 5 rows. Out of 5 rows, okay, Ravi. Okay, Ravi 504 is Ravi and 567 is Ravi. Okay, that's why here we get 50 Ravi and Ravi. Student name equal Ravi. And okay, how many rows? How many columns here? Student number, student name and age. Okay, that's why here we print student number, student name and age. Suppose here T dot SID. Okay, just only I wanted to print student ID whose name is Ravi. How to write that? T dot STUID, student ID, right side. This is the filtering. Okay, this is the output value. We wanted to print output value. What is the output query? We wanted to print output. And relationship name, student of T. And if you want to write condition, we can write the condition. And okay, T dot student equal Ravi. We write like this. Okay, then what is output? In this particular example, we wanted to print total table, means total table match with the specific condition. Here I wanted to print only some student ID. Okay, student ID, only student ID. What about your output? Here we get output only for this particular query. We get output only this one, student ID. Okay, condition. Okay, student name equal Ravi. Okay, that's why here we can get only student ID. This is about the tuple relational calculus. In the tuple relational calculus, working with the rows, okay, we can get the values. Next one is domain relational calculus. What is the domain relational calculus? What is domain relational calculus? The domain relational calculus was developed by Lecture and in the year of 1977. The domain relational calculus is filtering the variables using domain of the variables. Okay, it is used for filtering the variables, domain of the variables. Okay, the domain relational calculus same as a tuple relational calculus, but here we have to use connectivities are and. Okay, here we are using a connectivities are and or not, okay. This is essential. Okay, this is essential. This is a universal qualifier. Okay, to bind the variables. If we wanted to bind the variables, we are using @ symbol and or symbol. Okay, notation. What is the notation? Okay, A1, A2, A attributes P of, and what are the formula you have to represent inner attributes. Okay, I'm explaining with example. Okay, here we have same student ID, student name and age. Okay, student name comma age. Okay, we wanted to print student name comma age. Okay, belongs to student table, and here we have to write a condition and, okay, age greater than 20, age greater than 20. The symbol used for logical operations. Okay, this is represent and, this is represent or, this is represent not. Okay, suppose student name, I wanted to print student name and age. Okay, student name and age, actually wrong this one, student name and age. Okay, here it print age greater than 20. In the previous example also we check student table, age greater than 20. Okay, that's why we print this one, these two things. Okay, suppose I wanted to print, okay, I wanted to we are the domain relation calculus also called as a QBA. QBE, query by n. Okay, similarly first here we have to write the tuple, what you wanted to print. Suppose attribute values means attributes, nothing but output values. Here you have to write the common attributes. What are the attributes you have at the rate? Suppose in the employee table, we have some e number, e name, and e sal, and e address, like that. These are the common fields. Okay, I wanted to print e salary. Okay, suppose e number and e address, salary greater than some 20,000. Okay, here I wanted to print relation name. Okay, e number, comma, you have to take one variable, some t dot e number, comma, t dot e address. 1 minute, otherwise I will take my like this. Suppose you have EMP table. In the EMP table, e number, comma, EMP name, comma, EMP salary, and EMP address, and EMP mobile number, like this. Okay, we have EMP table. Okay, if you wanted to use QBE, okay, what is the syntax for QBE? Okay, first output attributes. What are the attributes you want to print? Okay, at the rate. Okay, either we are using this at the rate, we are using some specific symbol, and write the all the values. Okay, if you are considered this is A, B, C. Okay, employee number is A, employee name is B, employee salary equal employee salary equal B. If you are representing all the values, okay, here we have to print some suppose I'm not available that symbol, just I'm using dollar. Okay, at A, comma, at B, comma, at C, comma, at D. Okay, here A, B, C are nothing but these are A, B, C, D, E, like that. Okay, that's why already here we have to print output values. What are the output values you wanted to print? Okay, A, comma, suppose this is A, B, C, employee salary equal C, employee address equal D, some employee mobile number equal D, E. Okay, first you wanted to print employee number and employee address. okay, whose salary is greater than 25,000. Okay, for that we have to write a query like that. First, what are the values you wanted to print? A comma D, and okay, that is at the rate. Okay, remaining object, what are the remaining objects? B comma D comma E. Okay, now you have to filtering is nothing but pipe symbol. Now condition, what is the relation name? T dot emp. Okay, T dot emp, and okay, here we are using and symbol, logical and. What is the condition? E salary. Okay, means what is emp salary? Emp salary greater than 20,000. Okay, what is output? We get output only some employee number and emp salary. Okay, same in this example. Suppose I wanted to print like that. Okay, here we have to write, okay, all the values. Suppose if you think this is A, B and C. Okay, what do you want? You want to print only, some student names, age greater than 20, How to write that condition? First, what do you want? You want to print student number or all the values. Okay, student name. Okay, B, object B. Okay, at the rate. Okay, remaining objects B comma C, filter, and what is the relationship name? Student. Okay, T dot student, relation name T dot student. Okay, or student name directly. Here you have to write the student, and okay, and logical and condition. What is the condition? Age. Okay, C greater than 20, like this. Then we get only this condition. Okay, here we want print only student B. What is the A, student name. Okay, that's why we print only this one. We can get the output, this output only. Yeah, okay guys, this is about the domain relational calculus and tuple relational calculus. Okay, if you have any queries, please comment me. Next session we go with the very important, that is a SQL, introduction to SQL. Next session we will continue with the introduction to SQL. Yeah, please subscribe Eazy Btech channel.